All right, so let's start with operation questions.
You guys have questions?
This side.
Yeah.
Just general stuff about like using it for Django, pretty much.
Django.
Like,
Okay.
Yes.
Awesome.
yeah, come on.
Awesome. Awesome.
Yeah, 1, 2, 3, Django.
Awesome. Okay.
So this is something you all can pass around, has an on-off switch.
All right.
Just don't get in front of the speakers.
In this side. Leave one, yeah. Chop. This one here, and then you just.
How many of you have actually used the Azure Postgres service? Or not? How many of you have used the Azure Postgres managed service? Okay. All right, so since only one, let me kind of quickly introduce you what we have done, right? So at the same time last year at Build, we announced the public preview of the managed Postgres service, and about a month ago, we became generally available. So what this Azure Postgres service does is it takes the community version of Postgres and provides the similar capabilities of managed features that you otherwise see with databases like Azure SQL Database, right? So essentially what we have done is we have built on the same common platform that was built for SQL Database, and we have extended that platform to now include Postgres and MySQL. And we are actually now working to extend that now to add MariaDB into the engine as well. And one of the key priorities that that we chose, of course, it was for us to choose or not. We strategically took the decision that we will build on top of community versions of these open source database engines. That means these database engines are not a fork. These are the same that you would otherwise use on premises. If you download Postgres from postgres.org, it's the same bits that are running on our managed service. Now what you get with that is automatic backup and restore. And similar to Azure SQL Database, because we built on the same platform, now we have things like elastic scaling and built-in high availability. That means you don't have to set up replicas to achieve high availability. It's built in. Right? And that's one of the significant differentiator of the platform. If you otherwise compare to running, say, Postgres on Azure VMs, for instance, you have to set up 2 instances, set up replication, because you need HA. Everybody needs HA, right? Or you might be looking at running on Google or GCP cloud or AWS clouds. You have to set up multiple instances, set up replication to manage or get SLA around availability. With our service, you don't need to do that. The other benefit we get is also scaling. And scaling comes in the form of scaling for compute or scaling of storage. You can do both of them independent of each other, right? Scaling of storage is instantaneous. That means no application impact, in the sense of no application connections are lost. You can seamlessly increase the storage without even the application knowing about it, and what you get is increased IOPS. So you can scale for more IOPS, or you can scale for more capacity. And because we are built on Azure Service Fabric and using our own container technology, which is proprietary, we are able to also scale up your instances up or down instantaneously within seconds, right? So you can mostly right size how much resources or capacity you need to actually allocate to your instances, because now you have the freedom to go scale up or down. Oh, okay, I didn't know that. Real-time slides. Okay. Thank you, Rachel. So that's kind of the overall the context of the managed service. And one of the most important priority we took on since the start of the preview was based on the customer's feedback. We invested heavily on security. Right? Because for all of our customers, security is the #1 most fundamental, of course, besides performance and resiliency. So we are now we have passed most of the industry certifications like ISO, PCI, SOC, HIPAA, and we did this as we became generally available. Right? And then we also invested in bringing VNet service endpoints to the service as well. So it's currently in private preview, which we're going to be releasing soon in about next several weeks. We will bring it to public preview, which means now you can securely connect these Postgres databases to an existing VNet and configure it such that only the VMs within the VNet can access the database. So otherwise, in terms of the user roles, management, etc., is the same Postgres that you would otherwise use anywhere else. And all of those capabilities are actually brought to you without any challenges. Yes. Where's the? Yeah. Sorry.
So I appreciate that. There's a lot that I like about the Postgres offering, especially the scaling up, the built-in HA. I think that's fantastic. Operationally, one of the things that I need is read-only replicas for two reasons. One is actually to separate some heavy read-only microservices off the main database. The second is when we do a schema change, the way we roll out things is we set up a read replica and we wait for it to catch up. Once that catches up, we separate it as a standalone master in case we really F something up, which means, you know, fail something up. You understood that, right? And so that we can instantly transfer without having to go to backups to do a restore. So we can have very quick service restoration and then have a long operation to fix the interlude data. So that's something that we need. In addition, the cross-regional would be needed. But that's what I'm looking for that you didn't mention.
Okay, because obviously I didn't mention because we don't have it in the service today. And that's something that we have been working on, and the question was about readable replicas. So let me also mention how we are looking at the read replica scenario, because replication is fundamental to many different scenarios. It's for read scale, some implement it for HA, some implement it for DR, some implement it for applications, the distributed applications across the region where they want their localized application and want localized low latency access to the databases. So these are all the different scenarios that we see the application being asked for. The way we are looking at is starting from solving the simpler scenarios and then gradually moving towards the most complex scenarios. So we have already started our engineering work towards enabling readable replica to create these replicas within the region. And the scenario we are optimizing for is read scaling, right? And not for like high availability, like so that you can fast failover. I mean, of course you can do all of that, but our primary, like we like to use the word hero a lot in Microsoft. So we call this, everything we call is what is the hero scenario amongst these technologies. And the leading scenario is read scaling, and that's the first one that we will enable. So once we are through that, the next phase of that is going to be allowing users to create these readable replicas in different regions. And that is to address the global distributed applications that wants localized access to their databases in that region for low latency purposes. Because that's what we heard from many customers, that was the scenario that they're really wanting the readable replicas across different regions. Then the third phase of this is now how do we allow replication or these readable replicas to be used in a highly available or disaster recovery scenarios. That's a more involved scenario for us. And the roadmap for us is that we are expecting the readable replica within the region to be out by, say, end of June timeframe. And the second half of this calendar year, we'll be focusing on enabling it across regions. And we anticipate once we enable the readable replica within the region, to support it across regions is not going to be that big a leap for us to take. So we may decide to actually roll that out sooner. Of course, barring any negative implications we see around the network latency between the regions, because that will definitely come to play in how these replicas are kept consistent, and whether the readable replica will be out of sync very soon, what other underlying design challenges we'll face. Like I would say that we don't completely have a full understanding of that, but that's the thinking around replication as a whole. Yeah. Yes, sir.
How does updates work? What do you normally?
I can repeat the question.
Okay,
too.
okay.
Yeah.
Updates. How does updates work? I mean, if I test against a specific version, would you normally go and update when the latest version of Postgres comes out? Or?
Oh, okay. So the question was, how do we patch? Let me improvise that. Because first I thought it's insert, update, delete, right? So I was thinking transactional. Okay, so how do we patch? So with this service, you get automatic patching. What does patching means? So patching means any updates that we do to the minor versions. For example, you say you're using 9.6. Postgres 9.6, and the latest minor version is likely 9.6.13, I think. So the patching of 9.6.12 to 9.6.13 is handled by the service itself. And our untold promise is that we will patch the latest version, the latest minor version, within 30 days of it becoming generally available. So you can rest assured that the security updates and all the other things that gets released by the community and like those are getting patched continuously as part of our build process itself. Right? Then the major version updates, for example, you want to upgrade from 9.6 to say Postgres 10. And that is a different journey because it can break applications as well. So that we support, we try to bring and support the latest versions of these Postgres as quickly as we can. And then we leave it to the customers to decide when they want to actually do the upgrades. Right? So we don't do the major version upgrades automatically because it will break application compatibility or it can cause different. But minor versions we automatically patch. Does that help answer your question? Okay.
One more follow-on. So what's involved? Let's say I want to go from 9.5 to 10.6. Is that, do I have to migrate my data myself, or is that something I could just start from the GUI, upgrade, or?
Yeah. So the question is, if you want to upgrade from 9.6 to some 10.0 or 10.x, what does it take to do the migration? Right now, the answer is you do the PG dump and then you restore. We have not tackled that problem in the service because today we support 9.5 and 9.6. And 10 is coming within a couple of months. It's in development right now. And most of our customers are using 9.6 anyway, so that's so it's in terms of the overall priority of the different work items, we have not prioritized providing an experience for developers to orchestrate the updates. But that's in our backlog. We will when this becomes like a pressing need for our customers. But today you can do that using the PG dump and PG restore. Yeah. Any other operation questions?
How far back are you going to support? Does it follow whatever Postgres' still supported versions are? So right now you're doing 9.5, 9.6.
So
you maintain those till they reach end of life with Postgres, or are you going to have a different window for your support?
Okay, so the question is about how long do we support the older versions and what is our recycle plan? Our, again, untold promise is we'll always support the 3 most latest versions. We will have a deprecation policy. For example, let's take a real life example. So today we support 9.5 and 9.6. Postgres 10 is going to come be supported in the next 2 months, right? So at that time you will have support for 9.5, 9.6, and 10. when Postgres 11 comes out, we will start the deprecation process of 9.5. And we'll give users some number of months, up to maybe a year. We have not completely closed on that yet, to allow customers to schedule their migration plans to the latest version, whether it's 9.6 or 10, depending upon whichever suits your particular needs. So that's the overall plan. So Postgres releases their major versions every once a year. Postgres 10 was announced last September. This coming September, Postgres 11 will be released. And at that time, very likely, you can expect us to start the deprecation announcement for 9.5. So at any time, the net is that we'll support 3 major versions. Any other operational questions?
Let me actually ask back, is that sufficient for you? That's better for you? No, I mean, I'm literally, right? I mean,
It's
you
not
say, oh my
clogged,
God, this
so-
is like a disaster, right? Like if it's too fast or too slow, I don't know. Good, okay.
Any other operational questions? Or what was the next classification? I know there was a readable replica.
Oh, what was the next question?
Yeah.
Django.
Django, yes, favorite topic. Okay. I'm assuming that you're all familiar with web apps. Are you? So web app is a PaaS service, and it comes with the pre-integrated with Django template, and we integrate natively into that framework. So if you want to deploy a Django-based app, either you run the Django app on a VM, so we have no issues with that. But if you're really looking into an integrated experience of running a Django-based app, you can go to web app, and maybe if you go to the marketplace, we can show you the template as well. If you go to Azure Marketplace and search for web app Django, you'll see that our Azure database for Postgres is natively integrated into that.
You feel a little like a DJ?
Huh?
Sing with me. She's a DJ.
Sorry?
She's like, I feel like a DJ.
DJ.
So specifically,
Yes,
the one I would select.
correct. So do a create. No, hit the create button.
Yeah. I'm just highlighting that it's referring to the other.
Yes, yes, yes.
Equal.
Yeah.
So once this populates, it's going to give the create workflow for the Azure database with Postgres SQL Server. So you can click this.
Yeah.
And then let it know what you want that to be named.
Yeah. This is our blade.
Yeah.
So
So right
it's
now, from the time you make the web service, it's going to know that this is my database, this is how I talk to it. Similar goes for WordPress.
How many of you know about our HA architecture, how it's built? How is our high availability architecture built? Is that of interest? Okay.
Sure.
That favorite slide. All right. So this is significantly simplifying how we have designed the service, and this is very similar to how Azure SQL Database is architected as well. Like you have Azure, like you have the application that has the Postgres client, and when that Postgres client is trying to connect to your database, it goes through a gateway. So the gateway is the connection proxy, right? And the gateway also is the layer that identifies a connection coming in, which database in the backend cluster that belongs to, right? And for those of you who have tried our service, there's one thing that likely you've already been annoyed with, and that is when you try to authenticate or when you connect to the backend database, you have to use username and server name, and you wonder why. Like if I have to use Postgres on premises or on a VM, I don't have to do that. But why do I have, with the Azure Postgres, why do you have to do that? There are pros and cons with that. I mean, in why we have a gateway, right? Number one, why we need that username and server name construct is because the Postgres protocols doesn't understand or doesn't, like in the first authentication packet, doesn't preserve the server name. Or does not pass the server name as part of the protocol implementation, which means we have to explicitly like use that username at server name construct so that we can parse that at the gateway and then say that, hey, this server then maps to this particular node in the cluster, right? And then why do we have that? Well, it's not there just to give developers annoyance and try them to use some non-trivial stuff. The reason why gateway exists is that is very fundamental to how our built-in high availability works. For example, you see the client connection coming to gateway. The gateway is listening on the standard Postgres port 5432. And then it connects to the backend database, like that back to your instance. Now, suppose say that the database instance were to go down, or you were initiating a scale operation, right? The application client can still connect to the gateway, right? Only the backend connection is not taken place at that point. Right? So that's why we say that when the application has the connection retry logic, it'll keep retrying to the gateway. You still have a path open to start the connections, and then when the server is available, then it automatically connects to that backend database. Right? And now, after having talked to the gateway, the other elements is that the Postgres server that you see is essentially a container. So we are not running on a VM, and that's very important, right? Because when you see, like for example, when you're running on an IaaS VM or you're running in any other cloud, most of the times you're running your database inside a VM. And you all know that, I mean, shutting down or restarting a VM takes minutes, it's not seconds. So for any of our built-in properties, we have to be sure that you can recover your instances in seconds. Because we are using our own container technology, which is essentially a process, think about it as a process. It's not that we are running on Docker, right? Because Docker is not a secure container. So what we have done is we have built our own secure container based on a piece of technology that was used for releasing SQL Server on Linux. And the entire philosophy of that container technology is if we create an operating system which is a completely stripped down version of the OS, the attack vector of anybody trying to intrude into the process is very, very, very small. So that's the fundamental premise behind this, or philosophy behind this container technology. So we are able to spin this, restart these instances or containers in seconds. It takes 2 seconds for us to restart the instance. And then the second part of how the built-in HA works is now you have to detach the storage from the old instance and reattach the remote storage to the new instance. That takes another 2 or 3 seconds. It's not a big intrusive step. The variable is then the time it requires to crash recover the database. So for example, if you're doing a planned activity, so for example, you're doing a scale up of an instance or a scale down of an instance, that we treat it as a planned maintenance, wherein we do the checkpoints before we bring down the instance so that the recovery time after we spin it back up is very minimal. But in case of an unplanned failover or unplanned failure, suppose there is a bug in Postgres or whatever that is, and sec faulted or brought the instance down, then we didn't have the opportunity to do the checkpointing ahead of time. So depending upon how much ever transactions that were running at the time the instance went down, it will take like whatever the time it takes for it to recover and crash recover the database to bring it to a consistent point. And that is variable, and that is depending upon the workload that is being running at the time. Most typically we see that it's within the 45 seconds, but also to be very transparent, we have also seen in some instances it can be 5 minutes as well. Because if you are running if you have a very long running transactions without a commit, for example, right? So you have a transaction that has been running without commit and doing inserts for the last 15 minutes, and then we bring down the instance down. Now it has to go and undo all those transactions that happened over the last 15, 20 minutes, and for that to happen, it might take 30 minutes as well. Right? So that part is the variable part of the overall built-in HA that you get with the service. And the storage, we use the local storage. It's locally redundant storage, so the storage keeps 3 copies of the data. So if any one copy of the data is lost, the storage will automatically reconstruct the failed copy, and always make sure that you have 3 copies of the data. And then when you increase the size of the storage, you have one more click. No more clicks. Okay. Then no connection, no application connections are lost. The storage automatically seamlessly increases. So if you need more IOPS in our service, the IOPS scale with storage. So if you increase it increases at a ratio of approximately 3 IOPS per gigabytes. So if you need more IOPS, you scale storage, or if you need more storage, you just dial the needle, and then all you're done. Okay, what other questions?
Data migration.
You want to talk about data migration? All right, Shao. Or maybe before we go into the migration, let me also talk about some of the best practices, because I built those slides.
Sure.
Before you go to best
Yes.
practices, so how does the bug fixes work here? If I'm on premise, my might go deep cache, I just open a ticket with Red Hat. But this is not really your product. So who fixes Postgres if there's a problem creating a table, for instance?
Who fixes the problem if there's a bug in Postgres? If there's a bug in Postgres, obviously we work directly with the community as well.
So the customer will open a ticket with you, Microsoft?
The customer will open a ticket with us, and if there is a bug, we will work with the community. We have we may decide to patch as well. Okay. But the front side of the contact will always be Microsoft at that point. Yeah, thank you. So since the start of, and it's why I insisted on this slide is because also working with tens of thousands of customers who are currently running this service today, we've learned a lot in terms of what customers have fallen trap into or had difficulties in getting the best value out of the service, right? So one of the first thing that we have seen is performance, right? Why is my performance not at par when running on a VM or when running on premises? My performance, I don't get the same performance, and one of the very critical reasons for that is the network latency. It's very important that as you look at bringing your applications onto the cloud, and one of the things about, you're talking to me?
No, he's counting.
Oh, okay. He was like,
Sorry.
no, it's okay. So one of the major consideration is that you have your client applications and the database in the same region, and that you are getting the desired network latency in the application VM and the database. We do see a lot of applications that are written on Postgres are chatty applications. I don't know why. I would always expect that customers or developers write good stored procedures and good some functions and run the database logic or some business logic inside the engine, but most typically they don't, right? The applications tends to be very chatty, doing small selects, inserts, and so on, and therefore network latency plays a very, very significant role. Right? From the application perspective, they would see my response time is 10 times worse, 4 times worse. Why? Right? And one of the best practice and recommendation is to use the accelerated networking on the client application. So accelerated networking is a terminology used in Azure, but if you're familiar with SRIOE, that's exactly what it is doing. It's fast networking. And then you can get significantly better round-trip transaction latency when you enable that. There are certain VM classes that support this. Not all VM types support accelerated networking. So I also have a link here that you can reference which VM types and how you go about creating a VM with accelerated networking enabled. This is very, very important. Okay? And also I've given some guidance here in terms of what you should expect. If you run a select one from the application to the database, you should get less than 2 milliseconds. If not, that means like stop. Before doing a workload test, stop and see what is it required and why you're getting the low latency. The second one is storage. And on the storage side, we see that not many actually pay more attention to the IOPS. So it's one, knowing that the storage scales are 3 IOPS per gigabyte. And also, most of the cloud storages, and including our service, these storage subsystems, which are like we are built out of SSD, are optimized for throughput. They're not necessarily optimized for latency. And more precisely, these are optimized for read throughputs and not as much for write latencies. So you have to then make sure that your applications are architected or designed to work optimally under these conditions, right? And the way to do that is make sure that you have the right indexes and monitor your like how much close to the I/O limits that you're reaching, and also the fact that we support as low as 5 GB of storage, and you get 100 IOPS with 5 GB of storage, and then after 33 GB, it scales at 3 IOPS per gigabyte, right? All the way up to 6,000 IOPS. So, and then also, if you're still not getting the type of latency you need, and that's why we created another instance, another performance tier called memory optimized. Memory optimized increases the amount of memory per vCore. And if I had to give you a ratio on basic, so today we have basic, general purpose, and memory optimized. Basic has 2 GB of RAM per vCore. General purpose has 5 GB, and memory optimized has 10 GB. So if you have applications that have higher user concurrency, that needs to have, open more connections, or it needs to cache more data, memory optimized tier works out the best, most optimal tier to run your workloads. And then the compute. And here what I would like to highlight here is in the service we enable pgstat statements extension out of the box, which means as a developer you can use these pgstat views to figure out which transactions are consuming maximum time, and you can start to investigate which they are missing indexes, or there are table scans running, and therefore you're seeing a high CPU utilization, et cetera, right? Then one of the things that we have found, and this is after a lot of investigation and debugging, is because sometimes it's not very trivial, is many of these applications are not multi-threaded. So suppose say your application is single-threaded, and you say my CPU is less than 1%, but I'm still bottlenecked. I still cannot get more out of my more performance, and it happens to be single-threaded on the back end. So no matter how many cores exist on the database, it doesn't matter because you're limited by the single core, right? So that's a very important thing to watch out for, especially when you come across a situation that I'm not CPU bound, I'm not IO bound, I'm not memory bound, I'm not network bound, my performance is still slow, right? You've seen this as a common issue across many different applications, and that's why I kind of highlight that. Very important to watch out for that as well. Okay. So then many users of Postgres. Postgres is known for extensions, right? And we support over 33 Postgres extensions in the service today, including the most commonly used, like PostGIS, PG Crypto, for example, if you want to run encryption on user tables, you can use PG Crypto extension, so you can encrypt columns. You can use like many, like Earth Distance and all, like many common PG Buffer Cache for more performance monitoring and troubleshooting your queries and analyzing the performance. You can use all of these. And of course, the Postgres FDW, the foreign data wrappers, very, very, very famously, like very commonly used across many, many workload patterns, especially if you want to have different Postgres databases and mount the tables in a different instance. The foreign data wrappers is a very, very commonly used extension to be able to do that. Okay. Then how to bring your data. Okay. So while Xiao gets, yeah, question.
You mentioned that there are a number of, I'll use this. You mentioned that there are a number of applications which, in your experience, were very chatty.
Yes.
And so I don't know what other people's experience is. My experience of using things like Django, or Java for that matter, is that all of the tutorials, all the best practice materials that you read, all the reference designs and stuff, basically put all of the business logic in the application. So it's in Java or Python or whatever. And there's very little discussion about design that takes advantage of stored procedures or triggers or any of that sort of stuff. So I've often felt that, working with PostgreSQL, that 90% of its functionality is wasted because the applications all seem to just use it as a key value store. So it's not a question, just a comment.
Yes, I mean, so good observation, and it's also important to discuss in the same spirit, like an open, in terms of what type of users are coming to Postgres, right? And then you start to understand a little bit about why it's happening the way it's happening, and it's not just that that's the only thing that's happening. There are other things as well. For example, Postgres has become popular just over the last 5 years. So now it's become the most popular open source database now ranked by DB Engines, right? We saw that coming out a few months ago. And most of the new applications that requires strong asset consistency and et cetera, and really want a database, right? Go to Postgres in large volumes. What we also see as a headwind, and what we also see as an opportunity for Postgres and use case is also those customers that are coming off Oracle, right? Because Postgres has got more Oracle-like feel. Because of its PL/SQL support, because of the data types, which is matching and which resembles very close to Oracle, right? And now, as you would imagine, those customers or developers that are trying to come from Oracle to Postgres want to bring the same PL/SQL functions, etc. So they tend to become the heavy users of the database store procedures and functions and so on. Right? Because they want to take their existing, how they have implemented their business logic inside the database, which is what they've done in Oracle for decades, and now they want to continue doing the same thing on Postgres because they can do that very easily. But more of the modern applications, like let's say born the cloud apps, or suppose say you want to build an application from the ground up, these applications are being built without using much of the database functionality at all. They just need input, output. Like I want to store data reliably, I want to retrieve data reliably. So yes, you're right in some sense that it boils down to storing in key value store. But let's also not forget the entire value of this is coming in the form of SQL, right? that SQL, the rich flavor of SQL language in which you can do complex joins and bring data from like different tables and do some structured analysis, I mean, that is not going away, right? And therefore, it's not that bad a situation that you don't need anything apart from key value store. Yeah. But what Postgres has done really good at, and what the community has done a really good job at, is they have recognized these patterns and use cases and why the community went down like and enable support for JSON-B, JSON data types. So you can put unstructured data and query and use the same familiar SQL language against those unstructured data as well. So so that way, Postgres has really like taken the right direction in terms of bringing that SQL thing. So I still feel that there's a lot more value in that SQL and being able to store it in like structured format in like regular tables, or also in unstructured format in like JSON-B data types.
Yes, I just was trying to offer some feedback on why developers might write applications that do a lot of work in the application, but where it could be done in the database. That was just my observation.
Yeah, they do. Yeah, I mean.
So I just wanted to sort of add something. I've noticed using Django with Postgres, that when I actually look at the queries Django's running, it's running a ton of queries in a single Django operation. I'm curious if you've noticed with your service, people migrating, if they've had issues because of the latency and things you're mentioning, some of the performance, specifically with Django, and if when we're migrating, we should be careful about even going back through and checking what queries Django is running.
Yeah, I mean, yeah, so the question is, have you seen such patterns emerging from running Django type of applications? Yes, we have. And what we have seen more of along the same lines is the huge popularity for developers to use benchmark like pgbench. So pgbench is a standard benchmark with Postgres, which is like TPCB, designed in the 1970s, and it's basically like simulating ATM tellers, right? Like I'm a user teller, I'm doing my input output, right? So very, very chatty applications. Chatty application does 7 round trips for every statement. Yes, and that's the reason why I brought in that first comment about best practices, focusing on network. And we see these concerns all the time. And that's why it's super important making sure that you have the most optimal network between the client app and the database. And even then, sometimes you could see that you're not getting the desired latency at all or not, right? But that's just the way it is. But accelerated networking will bridge the majority of the gap that you would otherwise have. And once we have had those customers turn on accelerated networking, they've been happy about it. Right? So.
Do you know about the cached property annotation in Django? The cached property annotation in Django.
I'm not sure what you're referring to.
Django offers a facility where within a single request you can annotate a method or a property that stands in for a method as being cached, so that if you're actually retrieving a value multiple times during an operation, you'll retrieve it once and cache it.
Oh yeah, and I've been using like select related for nested tables, but my case is specific. I'm using Graphene to have a GraphQL API, and Graphene itself, it's not. I don't think it's built very well. So it's like it's sort of doing things in the worst way you could do them within Django. And then when we looked at performance issues, we found it was running like thousands of queries for some simple operation.
Yeah.
Another question for you?
Yeah.
Yes.
I want to know that how do you handle PII data in terms of encryption and decryption? Will
Okay.
Postgre will take care of itself like Azure database.
Mm-hmm.
They are through Azure SQL database. They have like one key and client key that they command for.
Yes. So the question here is, how does the service handle PII data? So I talked about like when I talked about the programmability, I talked about all the extensions we support, right? So PG Crypto is one such extension that the community has created, where you can encrypt through it's application level encryption. So you can encrypt your columns, you can encrypt your tables, select tables based on the encryption keys that you define, and that we support as part of the service.
So we need to forcefully use that extension to encrypt.
Correct. Correct. And the additional encryption that we provide in the service is the data that is stored on the disk, on our Azure storage. Both the data and the backups are automatically encrypted by default, using the AES 256-bit encryption.
Okay.
Right? But that encryption scenario is what is really trying to solve is if an intruder comes into the data center, plugs a disk, and then tries to read the data, will they be ever able to read the data? And the answer is no, because the data is all encrypted. But that's the scenario the data on disk encryption is trying to solve. But then we also have the encryption between the application and the database via SSL, right? But then there are applications or there are needs for the user to have their own encryption on the columns, specific tables, etc. And the answer from the Postgres community is the PG Crypto, which we support. Shall we now go to the migration?
Should I do migration? Yeah, sure. All right. So usually people will ask us, hey, how do I'm ready to actually try on Azure Database for Postgres or MySQL. How do I actually move the data in or bring the data in, right? Now, you look at this slide here, it's actually talking about database migration service. But before I go there, today, the easiest way that we tell people to do is actually PG dump and PG restore, right? And usually the question that we ask our customer is, how much downtime can you tolerate for your application? Now, customers tell us that, hey, I have a content website, like MySQL, they have a content website, and usually we have some maintenance time, right, that I can tolerate a downtime over the weekend. For them, and if the workload is actually not too big, like anything like 50 gig or something like that, the easiest way to do is actually PG dump and PG restore, right? There are some actually optimization that you can do also. If you're familiar with PG dump and PG restore, you can actually do a schema only, right? You move the schema first, then you do the data. You can also do a pre-data and also a post-data. That means that you move the schema, do the data, and also apply the index and foreign key later, right? That's the optimization that you can do in the native way, which is actually PG dump and PG restore. Now, some of our customers also tell us that, dude, seriously, I cannot tolerate like a weekend of downtime. It's mission critical applications. I have a very busy database and also application. So this is where we actually introduce an Azure Database Migration Service. We announced GA a couple days ago, right? And currently, it's actually, you can do a SQL Server to SQL Azure and SQL Managed Instance live right now on a database migration service. We introduced in a private preview for MySQL and also Postgres. The benefit that we actually like to introduce is actually the minimum downtime, which is a continuous sync. That means we introduce this capability for exactly the same scenario that the customers tell us that we cannot tolerate a long downtime, right? So under the hood, if you actually use DMS. If we have time later, I can actually do a demo later. What it does is actually it will do an initial load. Your database stay live on your source. I am just going to continuously syncing your data from the source to the target. Target means it's on Azure. Right? So then that means your database stay live. I'm just continuously like replicating over. You will see the data catching up, right? And then during the migration day, what you will do is you'll stop your application, stop taking in traffic. Then you wait for the last piece of data to actually migrate it over to Azure. Then you do a connection string cutover, right, from your source to the target, right? Like I say, if I have time, I will demo it to you guys later. So this is the second method that we recommend our customers to use if they have application that says that I don't want to do like a PG dump and restore everything by myself. Can I use a Azure service that do that, right? Another benefit right here is that you can also do it multiple database at a time, right? We're not migrating like one database at a time using PG dump and restore. And then you have to monitor when it fails, you have to restart again. It's actually just very cumbersome, right? So this is the method that we actually recommend our customers for a continuous sync benefit. Right. Any specific questions you have for the bringing the data in? Okay, cool. All right. So another thing. So before you actually decide and sit down and do the migration, we actually have a few things for you to consider right here, right? Like you see before, we Azure Database for Postgres actually support 9.5 and 9.6. So that means your on-prem, if they're on an older version, let's say a 9.3, right? So you probably need to upgrade them from the source, right, to at least a 9.5 or 9.6 before you actually bring that data in to Azure. Right. We also don't do a 9.5 to 9.6 jump. That means that if your on-prem is actually 9.5, we recommend that you use a Azure Database for Postgres, which is the same version, 9.5 to 9.5, 9.6 to 9.6. Yeah. All right. So you also need to do a little bit of homework of a sizing of your on-prem hardware and also spec versus the Azure Database, right, for Postgres. So you can actually see here some of the offering that we do, which is the basic, the general purpose, and also memory optimized. You can read a little bit about that, and depending on your workload, what is actually needed for those kind of offering. Right? Yeah, validate the Postgres extension. Sunil just say you might actually use an extension on-prem that is actually not offered yet in Azure. Right? Those you need to actually do the validation on that one. Plan for the migration of the users and roles. So today, a database migration service couldn't do user login and also role migration yet. A lot of customers tell us that, hey, you really need to actually help us to also migrate the roles and users' permission. We're working on that one. So that means right now, if you're actually planning to do a migration, you need to migrate yourself, right, on the users and also roles, right, from the on-prem to Azure. So like I say, the migration for Postgres and also MySQL is on a private preview. That means that if you actually go to Azure or Marketplace right now, you couldn't find it, right? So sign up on that page right there. It's AKAMS DMS preview page. I will contact you, and you just sign up with your email and your name and your type of workload, where are they hosting it. I will send you guys an email, then we can actually onboard you to DMS and try on the service. We actually like you guys to actually try on that service, and you gave us feedback on what else do you guys wanted to see, right? We know that migration is a very daunting task, especially for like really a big scale and enterprise grade of like the application. Yeah.
Were there any other questions that we could answer, or would you like Shao to show the migration demo? Okay.
5:30. 5:30. Yes. Question.
So I went to an AKS demo, and they were showing that you could use the service redirects for some of these things.
AKS is the Kubernetes.
Yeah.
What do you mean by the service redirects?
So it would replace out you setting up a container with Postgres running on it.
Yeah.
They gave a WordPress demo.
Oh, sure. I can show you what that looks like. You can tell me if this is quite what you mean. So if everybody heard the question, he was asking about the Azure Managed Service for Kubernetes. Let me open up this window. Sorry, first of all, in case you're not familiar generally, this is the Azure portal. This is where you could, one option for provisioning a PostgreSQL database. So it's just going to databases. It'll open up this window. Most of your configurations would happen in this pane. So here you would set, Shao mentioned we have 3 different tiers, the basic, the general purpose, and the memory optimized. You pick a hardware version. Gen 5 is the new one we're going towards, but they are priced the same. You can pick the number of virtual cores that you want, so that would be your compute. Compute also governs your memory, so it's number of RAM per compute core. Pick storage, so storage starts all the way from 5 gig, goes up in 1 gigabyte increments all the way to 2 terabytes is what's available. And like Sunil mentioned, IOPS scales about 3 IOPS per gig, so that's what would be shown here. You can pick up a backup retention period from 7 days to 35 days and choose to store your backup, either make it locally redundant or make it geographically redundant. What making it geographically redundant does is, in the event of some huge disaster at the data center, that database can be, or the server can be restarted in any region that Azure is available because your data has been redundantly made available in another server away from the data center that failed. So these are the major options that you would pick in this window. Okay. So specifically about the Azure Managed Service for Kubernetes, I have a cluster that's set up, and I'm opening the dashboard for this. So something that Kubernetes offers is this idea of you want to use managed services. Basically, you have a Kubernetes cluster. You like the way Kubernetes does its orchestration. But let's say there's a managed service that you want to use, like a messaging queue or a database, and you don't want to either set it up yourself or manage it yourself. You still want to use a managed service, but have that orchestration that Kubernetes offers. So Kubernetes has this concept of, service catalog and the service broker. So the service catalog interacts with the Kubernetes API server and tells it, it understands how the API server talks, and it's able to communicate between the API server and the service broker. So it keeps track of things that will be general across any managed service. That is the bindings, the provisionings, and keeping track of plans that are available. So that's the interface that understands generally that binding, provisioning plans. And then when you come to the service broker, that's on the far right, a service broker would be specific to the different cloud providers. For example, Azure has a service broker, Google has a service broker. And so that's how it's able to know specifically Azure managed services, like Azure Database for PostgreSQL. So if you wanted an Azure managed service, you would need to have both the service catalog and the open service broker running for Azure. And then once you do, I'm going to show you this in GUI form, but it's also something you can completely do from the shell, and I'll show you that as well. You can come here and select, for example, an Azure Database for PostgreSQL Server. You pick your tier, so very similar to what I showed you in the Azure portal, but this is going to bind directly to your Kubernetes cluster. Then you give the instance a name, build. And then you can set parameters here. So these are, again, very similar to the parameters you saw in the other window. The advantage of this is that Kubernetes is going to be bound directly to your Kubernetes cluster, and then Kubernetes is going to know about this server. And you might be thinking, again, like, why would you want this? So alternatively, you could have said, oh, I'm going to make my PostgreSQL, set up an image and bring the PostgreSQL up. But then you have to manage your high availability. You have to manage, especially something like persistent storage in Kubernetes is a lot to think about, because Kubernetes has this idea of things just go down and you can spin up another one, which doesn't work as well when you have like storage that you need to think about. So it's an additional layer. And so if you don't want to do all that, that's when something like a managed service comes in. If you don't want to manage high availability, scaling all those things by yourself. So I can click submit on this, and that server will be provisioned asynchronously. It's basically making the call. It's providing another interface layer. So this server already exists. I can add a binding. So in Kubernetes language, a binding is how it knows how to communicate to that Postgres server. So it tells it, well, it's still populating, but it would tell it the instance name, the secret. Let me expand and collapse again. Well, if it was showing, it would show the instance name, the database name, the host name. So you wouldn't need to think about that. Like if Kubernetes is the only thing talking to the cluster, it can read it from the binding. But if you wanted to know what that binding detail was, if for some reason you wanted to connect directly to the database, then you would be able to come here and get that information. And like I said, all this stuff I just showed in the GUI form could have been done like in a script. So this is VS Code. And I'm writing what the parameters of that server would be. And then I myself write that I'm requesting a binding. And this is what the binding file is going to be called. Were there any questions I could answer about that? Awesome.
Has there been any discussion about supporting logical decoding, streaming out of PostgreSQL?
So this would be with something like Event Grid, or specifically Postgres logical replication?
Yeah, like logical replication, but just the decoding part rather than the whole replication.
It is. So I don't know if you were here at the beginning, but we went into general availability at the end of March. And so our focus has very much been on getting the fundamentals in that people are looking for, the things like high availability and scaling. And then we're looking to broaden our horizons and then get those things like logical replication in. I know that's something that's a huge feature on Postgres 10 that people are looking for. Our major consideration there is about security and making sure that the slots and all those things are available only to the right users. And also that it doesn't take down your database and things like that. Yeah.
It in and like doing the restore and doing a count on the table, just very basic things. They seem to take quite a while. Like,
so you're saying you were on IaaS or on-prem, and then you migrated over to the Azure database for PostgreSQL Server?
Yeah, we had a PostgreSQL database on-prem with it was just sort of on an overloaded VM machine. So we were expecting similar or better performance out of the Azure PostgreSQL instance, but we ended up getting sort of an order of magnitude slower. Like.
Sure. Were you here for the performance best practices section by any chance?
Well, we've been through the best practices online, the latencies and whatnot. But I mean, the things that we're looking at were like even just a count internally. It seems like maybe the performance issues were IO bound, and we like even wrapping it up to 6,000 IOPS, we still had difficulty with the.
In that case, I would suspect it's something other than I/O. That is, because if you're able to scale it up and not seeing that match, and it looks like the throttle is not there, then it's something else, and we can discuss further to like look at what that might be. But in general, like as Sunil said, like if you're scaling up and you don't see the matching upscale in terms of usage of that resource, then it's probably pointing to something else that's hidden, and we can talk about what that might be in your use case. Were there any other questions I could answer? We have about 5 minutes more.
Is there any dev test pricing?
There is, Charles, is there any dev test pricing, was the question.
Oh, pricing? No.
They offer you free 30-day trial or something like that, but
like we generally have it on the roadmap to add Postgres or the open source databases to be part of the free trial, like this 12-month free trial that you get in Azure. This onboarding hasn't happened yet. But so you would get one specific size that you would then be able to use for free for like the 1-year duration after creation of the subscription, similar to other services.
It's just where we use the Visual Studio subscriptions, and then there's also the dev test pricing if you need to buy a big block, and it's usually like a 10 production cost.
Yeah. It's on our system. Yeah, so we don't have this at this. Obviously, you can use the credits that you get as part of the MSDN subscriptions against those services, but there are no special deeds at the moment for those.
Also, in terms of pricing, between basic, general purpose, and memory optimized, you can take a look at our pricing page. Basic tends to be a lot cheaper because it doesn't have those performance guarantees. So like you said, maybe not expected to be used for a full production scenario, but it will get you a feel of what the service is like at a cheaper price. Is there anything else? What did you say? Resources.
Not the one.
One second.
At the very end.
Why do you think it's on this?
This one. 28.
For example, using for like a dev testing, I come and talk to me and then you guys actually try on using the database migration service. That is actually much, because it's an Azure service, you don't have to do it yourself using a pgdump and pgrestore, right? Yeah, so my call of action is come and talk to me if you're actually interested to do a migration. So we just onboard you to actually use the Azure service, database migration service. Then you don't have to deal with like the pgdump and pgrestore mess, right?
Yeah. We can call this session closed, and you can come talk to any of us, me, Shao, Charles, Andrea, Jan. Come ask us any questions you have, any burning things. Thank you so much.